what this is saying here. So this looks a little bit strange because it's not actually drawn in there as the circle, as the radar screen would be, for the sonar, that type of thing that like Chris was suggesting. But it still helps you kind of understand. When we are given a polar coordinate, the way we are going to graph it, the polar coordinate is going to be in this format, where it is an R value and then an angle measure. So the angle measure might be in degrees, it might be in radians. So the center is what's referred to as the pole, and R, if you think about it, is our radius, right? So that's the distance that we will go out from the pole. And the theta is the distance that we rotate around from that standard position. We start at what's referred to as the polar axis and we rotate around. So this little note over here, if you notice, it says when plotting a point in polar coordinates, measure the angle theta first. So we're gonna rotate around whatever the angle measure is, and then measure a distance of R units from the pole along where that terminal ray would be. Notice that in working with polar coordinates, you use the second coordinate first. Okay, so keep that in mind. So let's take a look here. It says to locate a point with polar coordinates 5, 40 degrees, we draw an angle theta of 40 degrees counterclockwise so that it's positive. So that's this direction, right? So we move 40 degrees. And then from there, it's saying we're going to move out 1, 2, 3, 4, 5 to that particular point. Okay. So if you notice, that's the 0.5, 40 degrees to graph that. We've got some other graphs here. And like I said, it's a little bit strange to see just because it doesn't have the full circle on here, but I think it kind of helps you focus on the process a little bit better. So for this one here, let's change colors. This 3, 220 degrees, think about that. We're gonna rotate 220 degrees to here, to that location, and then from the pole, we're gonna go out 1, 2, 3 units, and then place a point there. So that's how we graph that point. I want you to see negative values here. So if you notice, this is saying 4, negative 30 degrees. So we're rotating in the other direction and we're going out 4 to that particular point. And then this last one is saying 110 degrees and then we're going out 2. Okay. All right, comments, questions, thoughts on those? We're gonna graph some ourselves out together, and then I'm going to have you graph some. If you look, the next page has a whole bunch of practice with this. Okay. I want you to notice, actually, first thing, we have a whole bunch of rings on this one, so we can go out by a half a unit rather than a full unit on each little circle that we see. So each ring in this case is going to be a half. So I want you to think about this. This is saying we're going to move to pi over 2. And actually, give me a second. My eyes start to go bug-eyed with this. So I'm going to draw in kind of those axes, darken that in just to kind of help with this. And I want you to think about this also. Like we've got kind of extra spokes, for lack of a better way of explaining it, than what we are used to seeing. Here's where our 30 degrees is. Here's our 45, and here's our 60. So they've included, they're drawing these spokes every 15 degrees, so you have to kind of take that into account also. Okay? But the thing to notice about this problem is that this is telling us to go in the opposite direction.
So we go through the origin?
So yeah, exactly. You're right, Ryan. We're going to go through the origin. We're going to go through that pole to go into the opposite direction. So we're going to rotate around to pi over 2, which means to the line going straight up and down, right? But then we're going to go out a distance of 1 through the pole, and we're going to go out 1/2 and 1 unit in that direction. So that's where point D would be. We're gonna label these. So you got it exactly right, Ryan. Nice. Let's change colors here. So for point E, we're gonna go to 240 degrees. So let's think about where that is. That's gonna be down to here. And then we're supposed to go out 2.5. So 1/2, 1, 1.5, 2, 2.5. Actually, still right where I drew my arrow. Was not intending it that way, but it worked out that way. So there's point E. And then this last one here, -5 pi over 6. So we are gonna rotate around to, oops, I went a little too far, to here. And then we're going out 4. So 1, 2, 3. I may have just gone one too far. I hope not, but I may have. Nope, that looks good. There's point F. So you're going to your -5 pi over 6 and then counting out from the pole 4 units. Okay. Questions? So try these yourself, make sure you're labeling the points, and we'll go over them in a minute. I'm gonna record this. The difference of the with the x coordinate, Chris, is this. So for this example, you would rotate around to this place, right? If we were doing if it were a +4 here, then we would count in this direction and your point would be down here. Okay, but because it's going negative, we want to go in the opposite direction along the spoke, go through the pole and go in the other direction. So that's why we end up here at I, up there. I don't know, does that help? Okay. So yeah, J, both of those were negative. So -3 pi over 4 is equivalent to 5 pi over 4. But then we're gonna go across the pole 2 units. For K, we're going to pi, but then we were counting through the pole 1, 2, 3, 4. And then -7 pi over 6 is equivalent to that 5 pi over 6, but we're going in the opposite direction there. Okay. All right, how did we do on those? It just takes practice with these. Monday, you are gonna have some serious practice with this. You're doing two of you guys are gonna be gone because they've got AP exams, so I gave them the graph already. You know how way back when you first learned about rectangular coordinates, your math teacher gave you this fun connect the dots, dot to dot graph that you had to color and draw? You're gonna do that with polar, so you're gonna draw. Don't give me that look.
It's be fun to draw and color in, but to graph the points is gonna be.
Yep, but it's gonna give you great practice, and then you're gonna make your own. You get to make your own. So think about the difference between if we're drawing something that's. Notice what it says here, and it should make sense to you. It says polar coordinates are not unique. We can represent the same point in many ways. So if you think about it, all of these points over here, they had a negative R value. They had a negative distance that we were going, so we were going through the pole. So we could think about or figure out a way to represent this particular point so that it was going in the positive direction, right? So there are a whole bunch of different ways that we can represent the same exact point. So similar to what we were talking about on the unit circle where we have coterminal angles, we're going to have a similar process here. So 2 kind of formulas that we use to find or represent additional pairs of polar coordinates besides one that might be given, okay? So I want you to think about this. It says one way to find more points is that we're just going to add or subtract 360. So that should sound familiar. That's just coterminal angles, right? So we're going to add or subtract 360, or what's equivalent to 360, and that's 2 pi. So that's just basically rotating around, right? So this formula tells us we're just rotating around another set of degrees. So what this is saying is that we are going to keep the R value the same. We're just going to add or subtract so that we're rotating around more one way or the other, okay? But the other way that we can get to that same point is by switching directions, going through the pole, right? So if you notice on these, we're switching the direction and we're going through the pole, so we have a negative R value. And in that case, what we're going to have to do is add or subtract 180, or what's equivalent to 180, which is pi. So for these, we are going in the opposite direction. Opposite direction. So let me show you how this is going to work, how we use these formulas. Okay. So if you notice this first example, it says find 4 additional pairs of polar coordinates that name the given point. We're given the R value and we're given degree measures, so we're going to add or subtract 360 to get 2 of them. So we're going to rewrite one of the points as we're going to keep the R value the same, but we're going to do 240 plus 360. And then we're going to do same R value and we're going to do 240 minus 360. So in other words, we get a new point 5, 600 degrees, and the point 5, what is that, negative 120 degrees. Okay. So that's 2 of the points. The other 2 points we're going to get by switching the sign for the R. So we're going to have negative 5. And then we're going to add and subtract 180 degrees. So we'll take our 240 and we're going to add 180. And we'll take our 240 and we'll subtract 180. So in other words, the point negative 5, what does that give us when we had 240 and 180? 420 degrees, and then negative 5, what is that, 60 degrees. So there's 4 other points. They're written as polar points, but they would represent the exact same point as this 5, 240. Because it's just telling us to rotate around one way or the other, or go through the pole and then rotate to get to it. Okay? So try the 2, pi over 6 yourself. We'll kind of, check those answers, but then we're going to take it on the next page. They kind of give you a little bit more specific directions on how to deal with these. So we're going to take a look at just one of these. We won't do both sets, but we're going to do one of these sets. Okay? And then I'm going to switch to the other recording. Okay. So here, what it's saying, it says plot the point P with polar coordinates 3, 225. So we don't have this drawn as the circle, as the sonar screen, like Chris called it, but we can still kind of draw this as you saw to begin with. So what we would do is we would show that for 3, 225, 225 is going out in this direction, and to show the 3, we would want to draw 3 little hash marks there, label our point P. Okay, if you wanted to put a little 225 out here, you could you don't need to, but just to kind of help you keep track of thinking about where that would be. All right, so we're gonna come up with what the equation is, and we're gonna graph the points based on those equations. So we're gonna do what we just did with the using the same or different R value, that type of thing. So let me explain here just a second. It says, if you notice, find another pair of polar coordinates of P with the following properties. We're gonna hold off on doing B and C. I'm gonna do D first, just because D is, if you notice, D is saying R is still positive, so we're still gonna go in the positive direction. But it's saying let's subtract the 360. So if we do 225 minus 360, we get negative 135. So in other words, point D, it's equivalent to this point 3 comma 225 degrees, but it would be 3 comma negative 135 degrees. So let's think about how we would graph that, right? If we're doing negative 135 degrees, we're gonna move in this direction to negative 135, but we're still going out 3 units from the pole, right? So that point, it's being graphed exactly the same. It looks exactly the same as that initial point, but we wrote that point differently and we rotated differently to get to it. All right? So let's look at these middle two, because these have, if you notice, it's saying the R value should be negative. So remember, that means we are going to add or subtract 180. Okay? So if we want our R value to be negative, we know the equations, the point is going to be of the form negative 3 comma something. And so we're going to take our 225 and we're going to subtract 180. That's what the formula tells us to do. And so we get 45. So think about how we would graph that. This is for graph B. We're gonna start here, original position. We're going up to 45 degrees, this direction. Oh, but then, by the way, we're gonna have to go backwards through the pole and in the opposite direction. So I just want you to see, you're still getting to that same point each way, right? This is the process of what it looks like to graph, though. Your movement's a little bit different in terms of graphing them, right?